Democritus. I think I've heard of him. I should find out more.
Hey, John.
Hey, Drew.
What's up?
Nothing much. I'm researching this guy named Democritus.
Why?
I found this note yesterday in front of my house and I wanted to look into it.
Alright. We gotta go, though, so back up and go.
Alright. I found out that Democritus was a Greek philosopher in 400 BCE. Democritus theorized that eventually you would reach a smallest unit of matter. This matter he called an atomos, which means in Greece, indivisible. Take this apple, for example. Democritus believed that I could take this apple and cut it in half, and cut it in half, and keep cutting it in half, until eventually I would reach a smallest unit of matter. Another philosopher, Aristotle, believed that you just needed a sharper knife, and you could keep cutting it indefinitely.
So what were you doing researching Democritus again?
I found this note, and it was interesting, so I looked him up.
Just, decided.
Yeah, basically, it's just like that.
John Dalton.
Might be related. Let's look him up.
What I discovered about John Dalton is that I was an English school teacher in math and chemistry and lived around 2,000 years after Democritus. He developed an atomic theory that says matter is made of atoms, atoms are indivisible and indestructible, atoms of the same element are identical, atoms of different elements are somehow unique, and atoms combine into simple whole number ratios. He listed these elements in order of increasing mass.
Knowing that matter had one indivisible particle, Dalton made an atomic model which was basically a solid sphere.
So yesterday, the strangest thing happened. I was looking up some more information about John Dalton, and this ad kept popping up. Every time I closed it, it would just pop up again. So finally I decided to read it. It's about this guy named Dmitri Mendeleev. He graduated from the University of St. Petersburg. He created the first periodic table in 1869, and he also predicted the discovery of new elements, eka-silicon, eka-boron, and eka-aluminum. He also changed the order of some of the elements previously discovered.
So, who's doing this? Who planted the pop-up? Who planted the notes? What's going on? We're gonna have to find out.
So last night I got a call from like a block number. And I pick it up and it says, in a robotic voice, one name, J.J. Thompson. It hangs up. I don't know. So I decided to look him up. I thought he might be related to this whole ordeal. And it turns out he is. He was more active in his career at the end of the 19th century and attended Cambridge University. He did experimentation with cathode ray tubes. And he determined that the cathode rays were negative because when he induced an electrical current, they always were attracted to the positive side. Observe. That's what would happen when there was no electrical current. But when he induced it, it always floated towards the positive side.
Using his cathode ray experiment, Thomson determined that a very small negatively charged particle caused the attraction to the positive. What he discovered was the electron. Using this knowledge, Thomson modified the previous atomic model to a new one. This model is called the plum pudding model.
Alright, recording. Ernest Rutherford.
That's weird.
I don't know, someone's messing with us, dude.
We should investigate this.
Alright.
And so what we found out was that Rutherford was a graduate from the University of Manchester, and he was a pioneer in radioactive activities. Rutherford, he did one experiment where he took positively charged alpha particles and he fired them through this very thin gold foil. And what he noticed was something very similar to this. And as you can see, the laser is being deflected off at these weird angles. And when Rutherford did his experiment, what should have happened was the alpha particles should have gone straight through the gold foil and just have been one laser at the other end. But instead, it was deflected at all these different angles, some of which deflected straight backwards. So, Rutherford concluded that there must have been a very highly condensed nucleus that was positively charged in the center of the atom. Thus, he concluded a new model for the atomic diagram. This model consisted of the electrons and then a very condensed nucleus that was positively charged in the middle.
I couldn't even believe it with my own eyes, but somehow this guy had managed to find my car and, once again, place another mysterious note.
After discovering the mysterious note on John's car, Robert Millikan as it turns out, we found out he attended the University of Chicago and did most of his important work in 1910. He conducted the oil drop experiment, which was designed to determine the charge and the mass of the electron. What we have here is basically a model of the oil drop experiment. We have this, our oil, our positive, and our negative, and we have an electrical current running through these. Now, Millikan would basically drop a neutral piece of oil through a hole in the positive slate, and then zap it with a X-ray gun, which is part of the electromagnetic spectrum. If you did it too much, it would go up, but if you brought it down and adjusted the electrical field just right, then he wouldn't be able to determine the mass of the oil drop, the force of gravity, and because he knew the electrical current, he could find or solve for the only remaining variable, which was the charge of the electron.
Last night, another anonymous message came to me, this time through a text. The text stated 2 words: Niels Bohr. After a little bit of research, I found out that Niels Bohr made the Niels Bohr model. The Niels Bohr model was the same as Rutherford's model, except instead he described the electrons in levels. The levels were something that could be changed if you zapped the electron. This explained why fire was green when burning copper and red when burning potassium. It seemed to us that this guy would never get off our backs. The message this time was on this wrinkled up paper and read quantum mechanics. Drew and I once again set out to research this. We found 4 main things: the Schrödinger equation, Heisenberg's uncertainty principle, Pauli's exclusion principle, and the Aufbau principle. Erwin Schrödinger theorized that when electrons are behaving wave-like, they can be described mathematically. The location could never be known exactly, and the location could only be guessed at. He used 4 variables to describe the electrons in an atom. These variables were known as the quantum numbers. The first was N, the principal quantum number. N described the energy level. N were numbers like 1, 2, 3, and 4. The second variable was L, the angular momentum number. This described the shape of the orbital. The values in L were n-1. The shape of L equals 0 was a spherical orbital and was called S. L equals 1 is a dumbbell-shaped orbital and is called P. L equals 2 is a clover-shaped orbital and is called D. L equals 3 is a many-lobed region and is called F. M sub L was the magnetic quantum number. It described the orientation of the orbital in 3D space. It had integers from -L to +L. S orbital has 1 orientation, m equals 0, p has 3 orientation, m equals -1, 0, 1, d has 5, -2, -1, 0, 1, and 2, and f has 7. The last of the quantum numbers was m sub s, the spin quantum number. All this did was describe the spin of the electron on its own axis, which was either -1/2 or +1/2. Using the quantum numbers, Schrödinger developed the Schrödinger equation. This can be described as E times psi equals capital H with circumflex times psi. This equation was used to estimate the location of electrons. Heisenberg, a German scientist, was attempting to explain the electron but couldn't describe them because upon close measurement the electron changed. It was this that made him come up with the Heisenberg uncertainty principle, which stated that there is a fundamental limit to how precisely one can know the position and momentum of an electron simultaneously. This basically meant that the location of an electron could never be found. Wolfgang Pauli developed Pauli's exclusion principle. This stated that no two electrons can have the same four quantum numbers. The Aufbau principle stated that an electron will always occupy the lowest level available. This allowed people to determine the electron configuration and classify the atoms by electrons. Hund's rule stated that electrons occupy the empty degenerate orbitals before pairing. Like in the picture, each of the spaces must be occupied before finally beginning to pair.
They are watching us, and you too.